In our properties of alkenes and alkynes, we'll see what physical properties differ for alkenes and alkynes from alkanes, which we studied previously. We'll also see some real-life examples of alkenes and alkynes. All right, there's a lot to look at here, but I wanted it all up at the same time. So follow me because I want to be able to show you both of these side by side. All right, so on the top we have ethylene. Ethylene is a common name for the alkene ethene, meaning it has two carbons and a double bond. So once we create this double bond in ethylene, it's going to change the shape of this molecule. So these carbons, instead of having a tetrahedral shape with 4 atoms on it, when we form that double bond, each of these center atoms is now going to have a trigonal planar shape to it. So it kind of kicks out those hydrogens off to the side, and this is what our ball and stick model would look like. Ethylene is a common fruit ripening hormone, and the way that we use it, or maybe your produce people use it at the grocery store, or your agriculture people use it before the food even gets to the store, is they will pick the fruit green, like you see a banana here, and then when it's ready to ship or upon shipping, they're going to spray it with ethylene, which is a gas. It's the structure that we're looking at, and that causes the fruit to start to ripen. And the funny thing about fruit ripening is the more ethylene gas that's produced, so if it gets a little signal and it starts to notice there's ethylene gas, it will cause a positive feedback response, and then more ethylene gas is going to be produced. So it's going to trigger ripening in all the other fruit or produce that are close by. So there's that old saying, one rotten apple doth spoil the bunch. That is totally true based on chemistry, because if you have one rotten apple in a barrel, it's going to produce that ethylene gas, and it's going to cause all the other apples to ripen and eventually spoil as well. All right, looking at an alkyne, down below, notice when we remove 2 more of those hydrogens and we form this triple bond, we have now changed the molecule into a linear molecule. So it's straight across, and we can see that in our ball and stick model. Acetylene is the common name for ethyne. Acetylene is used more commonly than ethyne. It is a triple bond. It is an alkyne. We see acetylene used in welders, and this is a cutting torch that you're seeing off to the left. They use that gas, light it on fire in the presence of oxygen, and you can cut things like metal with your flame. It's pretty cool. All right, let's get to the nitty-gritty of the physical properties of alkenes and alkynes. We kind of lump these guys together because they're both unsaturated hydrocarbons. Just like with alkanes, they're still only made of carbons and hydrogens, so they're still going to be nonpolar, and therefore they're still going to be insoluble in water and soluble in organic solvents. Alkenes and alkynes tend to be more reactive than alkanes, and that's due to the presence of a double or a triple bond. Those are both much more reactive, and as we move later into this particular chapter, we're going to see what some of those reactions are and how easily they occur without the presence of a catalyst. One of my favorite properties, alkenes and alkynes are still combustible. We saw that with acetylene on the last slide. Alkenes tend to be abundant in industry. They're abundant in plants. We saw our ethylene example in animals. Oftentimes they're fragrant. But alkynes we don't tend to see very many in nature. Remember, they're very reactive. A lot of times that double bond gets broken down, or the triple bond, excuse me, gets broken down into a double bond and eventually a single bond. So not very many exist in nature.